Welcome back. We're going to continue our discussion on gas laws, and the third law that we're going to look at is Charles' law. As with Boyle's law, which compared pressure and volume, Charles' law compares volume and temperature. So as with the other laws, is based off of the ideal gas law, which is PV equals nRT. R is constant. We're comparing volume and temperature, so pressure has to be constant. So we're comparing V and T. Okay, the two variables are on either side of the equal, that's directly proportional. If they're on the same side, then that's inversely proportional. So if you work your algebra, then you end up with this expression, right? So volume is directly proportional to temperature, and pressure and number of moles are kept constant, right? So it's very evident, right? You see a balloon, you fill it with certain amount of gas or air, whatever you want to do. And then you put one in boiling water, and then you put the other balloon in ice water, or even better, dry ice or liquid nitrogen, which is even colder than ice water. You see the balloon shrinks, right? So when you put more temperature, as in boiling water, the volume goes up. In ice water, as in the temperature is low, the volume goes down. Now this goes back to these two goes back to one of the postulates of the kinetic theory of gases, or even the introductory slide where I said the pressure of the particle depends on the kinetic energy of the particles, right? So it's all related, right? So more temperature means more faster the particles will move, more pressure means more volume. Low temperature means particles are not moving as fast. In fact, they're not even moving as much. So there's not going to be that much kinetic energy. So kinetic energy is directly related to temperature. That is, more temperature, more faster things move. Low temperature, things move slowly, right? So here's a problem. Calculate, again, when it's temperature in the equation, you must convert the Celsius to Kelvin. So 20 degrees is 273 plus 20, that's 293 Kelvin. Now this is the volume at this temperature. So V1 is 6 liters, T1 is 293 Kelvin, and V2 is 4 liter, T2 is what? So it's directly proportional. So before you even do the problem, you should visually imagine that because volume went down, temperature should also go down, right? So when you calculate, the new T must be less than 293. So V1 over T1 would be 6 over 293 equals 4 over T2, right? So that'll be 6 over 293. So that's 0.02, right? T2 equals 4, right? So T2 would be 4 over 0.02. So it's 200 Kelvin, roughly 200 Kelvin, right? And clearly our hypothesis was right. Because volume went down, temperature has to go down, right? And here's a practice problem that I want you to work it out, and then it'll be part of your mind thoughts, right? So stay tuned for the next gas law.